Welcome to section 4.3. And in 4.3 we're going to solve these systems of equations using what's called the elimination method. Now with the elimination method, the reason why they use the word elimination is they want you to eliminate a variable. That's hence the name. So what are we talking about when we talk about eliminating a variable? Well, let's write these two equations down. There's one equation, the first equation. And here's the second equation. Now, here's what interesting observation is that here we see a plus y and a negative y, and your natural inclination is to say, well, they cancel, and they do cancel, because in the elimination method, there's no substitution involved. That's a separate technique entirely. But in this method, what you're using is the idea that you could simply add these two equations term by term. As long as you do it on one side, you do it on the other side, everything is balanced. So if we add those two, you see x plus x is 2x. Okay, the whole idea is that we're eliminating the variable y because we see a plus y plus a minus y, and that cancels. And that's equal to negative 6 plus 8. That gives me 2. And so if I solve for x, I get 1. And so there's half the answer right there. Now to get the y, you got to take this 1 and plug it into whatever equation looks the easiest. I'm going to go with the first one. I don't know, because I see the plus sign. I guess I'm a positive guy, and I want to go with the plus sign. So what you're going to do is plug in x is 1 plus y equals negative 6. And if I subtract 1 from both sides, I get negative 7. So the point that solves both equations is 1, negative 7. Let's put that right in there. Type an ordered pair will do. 1 and a negative 7. Hit enter. Fantastic. I'm feeling good. Got a green box. Now, you know what? I'm going to let you do this one. Okay? In this case, what you're doing is I see an x and a negative x. That's great. When you see a variable and it's negative on another equation, simply add the two equations, and that variable gets eliminated. And then from there, it looks like exactly the same technique that I showed you with the first one. So I want you to have a little bit of fun on your own. Okay, what about this guy? This one's a little bit harder because, you know what? I don't see a variable and its opposite. See, if I added these two equations, the y's don't cancel. You end up getting 2y. And these don't cancel, you end up getting 5x. So how do you do a problem if you don't see a variable and it's negative? Well, here's what you do. File, new. Okay, write these equations. 3x plus y equals negative 3. And write this down. Okay, well, as it stands now, adding the equations isn't going to help you at all. But what you got to do is say, well, if the simplest variable to sort of eliminate is this y, because it would be really nice to have a negative y on the bottom. Here's how you get a negative y on the bottom. You're going to take this entire equation, both sides, multiply by minus 1. And when you do that, you get minus 1 times 2 is negative 2x. Negative 1 times y is negative 1y, which I'll write like that, negative y. And negative 1 times negative 2 is 2. Now, it's okay for you to go ahead and add these two equations. Because actually, this equation and this equation are exactly the same. They just look different. I have a variable and its opposite. That's fantastic, because 3x plus a negative 2x is x. Y plus a negative y cancels the y. Negative 3 plus 2 is negative 1. And there you go. We solved it. We got half the problem. We've got this right here. We've got the x is negative 1. Now we got to calculate the y. and pick any equation you want. One's no better or easier than the other. I'm going to go with the first one. So I'm going to plug in x is -1. So 3 times -1 is -3 when you multiply 3 times -1. I don't know what y is, but plus y equals 3. I guess what I'm going to do, oh, -3, -3, it's -3. That's right there, -3. I'm going to add 3 to both sides to get rid of the 3 from the y. I get 0. Okay. There you go, 0. Oh, not there. Put the 0. God, well, I can't seem to find it. 0. I still can't get it. All right, 0. That should be it. -1, 0. Good job. Fantastic job. All right, so now this is what you do. This is exactly what you do. Let's take a look at this next problem, 4. Looks pretty tame to me. It's the same thing. 6x plus 5y equals 5. And over here we have 6x plus 5y equals -5. And I'm liking the equation because here I have 5s, the y's have 5s, and here's the x's got 6s. The only thing that's missing is the negatives. So I'm going to take that bottom equation. I'm going to focus my eyes on the y. I want to eliminate the y. And if I want that, this has got to be a -5. And the way you get that is by having a -1 here. -6x minus, see, I'm multiplying through the parentheses, -6x minus 5y equals -1 times 5. -5 is 5. Now let's add these two equations. So the whole idea behind elimination is you can multiply an equation by a number. As long as you multiply that equation, both sides, by that number, you still have basically the same equation. And then you can add equations like I'm doing here. So I multiplied this by -1 to come up with something. And the whole idea, I wanted to get rid of the 5y. 6x plus a -6x. Wow. 0x. 5y plus a -5y is 0y equals 10. 5 plus 5 is 10. So 0x plus 0y is equal to 0. And I got rid of all my variables. And that's not a good thing when you get rid of your variables, because if you get rid of your variables and you did it right, it can't be A. It's got to be one of these oddball conditions. And so here's we have a situation where 0 equals 10. Now, if you remember from the first section 4.2, if you come up with a false statement here, because certainly 0 equals 10 is false, what that means is that there's no solution. There's absolutely no solution. Okay, if this were a true statement, like you ended up getting 0 equals 0 or 5 equals 5, then you would have infinite many solutions. So that's how you remember which one you do. Okay, fantastic. Okay, so I'm going to go ahead. I think I could sneak this here, right over here, and just say 5x minus 4y equals 4. And this is -10x plus 8y equals -8. Okay. You pick a variable. What variable? I'm sticking with this y. I don't know. For whatever reason, I have a problem with y's. So I'm focusing my eyes on y's. This -4 should become -8, because -8 plus 8 would be 0, and that would get rid of it. And how do I get a -8? By multiplying the whole thing by 2. And when you do that, you've got 10x minus 8y equals 2 times 4 is 8. And now what we're going to do is add these two equations. And look at this. Negative 10x plus 10x, 0. 8y plus negative 8y, 0. So this side is 0. Negative 8 plus 8 is 0. Oh, okay, so basically that's true. And if it's true, I get infinite number of solutions. There you go. Halfway done with this homework. Okay. All right, let's see what we're going to do here. Don't save this. File, new sheet of virtual paper. 2s plus d equals negative 3. Okay. This is 5s plus 3d equals negative 9. What to do? Now, getting rid of s is would be problematic because you could get rid of it. What you want to do is make sure you want to have the same coefficient and have the negative so that when you have the same coefficient and the negative, they would cancel out. For instance, I would have to multiply the top equation by 5, multiply the bottom equation by minus 2. This would be 10s minus 5s, and that would get rid of the s, but that's a lot of work. I don't want to do a lot of work. I think the best thing to do here is I see a d and a 3d. How about if we multiply this top just once, one equation by 3? Negative 3, negative 3. Put the answer down here. Negative 6s minus 3d, multiplying through by negative 3. And negative 3 times negative 3 is 9. And what we have here is 5s minus 6s is negative s. The d's cancel. Negative 9 plus, adding these equations, negative 9 plus 9 is 0. Don't be afraid of 0. That's a number 2. And if I divide both sides by negative 1, I get s equals 0. Okay, now let's see. S is 0. I'll put that in there before I forget. So we have an answer. It's not a weirdo problem because we still had a variable. And just take S, take an equation. I would go take this guy right here, the top one. 2s is 0 because if I plug in 0, 2 times 0 is 0, plus d equals negative 3. I mean, that's what it's got to be. Negative 3, hit enter, and we got a good job. Now this guy is going to take a little bit of work. And there's no way around it. No way around it because of the numbers that we have here. So I'm going to need another sheet of paper. New. Okay. Put that in there. 7x minus 6y equals 14. This is 6x plus 7y equals 97. Ooh, that's a big number. Okay, now what to do? Well, which one would be the easiest variable? One is no easier than the other. The only thing that I notice here is up here I have a negative and this is a positive, and that's good. You need that to get a 0 one way or another, but these numbers aren't the same. So what I'm going to do to make them the same, to get rid of the y, is multiply that by 7, and this guy right down here, I'm going to multiply that by 6. So we actually have to multiply both equations by numbers. So here's what we're going to do. We're going to put the answer to that problem up top here. 49, we're going to put it down here. 49x minus 42y equals 7 times 14 is 98. Okay, and so the bottom is 36x plus 42y. That's nice. That's good because we know that's going to go away. And then we have 6 times 97, which requires me to have a calculator. I have my calculator in my hand. I'm going to type in 97 times 6, and I get 582. 582. Now these numbers are scaring me. I hope they're right. Okay, now add these two guys. Add those. 49x plus 36x is what? What is that equal to? That's equal to 85x. The 42's cancel out, equals. Now I'm going to add those two numbers. That looks like it's going to be 0, carry to 1, 18, 680. Now, if I divide both sides by 85, I bet you we'll get a whole number. I'm going to take my calculator. If it's a whole number, I'm feeling good about this problem. It doesn't, mathematically, it doesn't have to be a whole number. It's just that they wouldn't be that mean to you starting, in Algebra 1, that you'd get some weird number. I get the value 8. Okay, so x is 8. That means it's the very first part of that point, 8. Now, what do I do to get the y? Well, you try to pick an equation that looks easy to deal with, and there's one is no better than the other, so I'm just going to go forward with the first one. Okay. Plug 8 into x up here, so 7 times 8 is 56. Minus 6y equals 14. I'm going to subtract 56 from both sides. And that looks like it's going to be minus 6y equals negative 42. Okay. And I guess if I divide by negative 6, I get y equals 7. Let's check our answer. Nice. Yes, yes. Still happy after all these years that I can get these things right. Nice, nice, nice. Okay, let's clear this board. Don't save. Start off nice and fresh. File new. Okay. Move this over here. Okay, now let's take a look at this problem here. What strikes me about this problem is it doesn't look like the problems we had before. The problems we had before, we had a column of x's, a column of y's, and a column of numbers. I'm going to make that happen here. See, the first equation looks good. 6x plus 10y equals 6. Okay, that looks good. This bottom guy doesn't look right to me because that 8 is not in the right position. It's got to be on this side with all the rest of the normal numbers with no variables. I'm going to subtract 8 on both sides. If I subtract 8 on both sides, that goes away, and I have a negative 8, 0 minus 8 on this side. And over here I have a minus 3x, a column of x's, and a column of y's. Okay, so it's looking better. I see a 10 and a negative 5. If that were a negative 10, that would be really good. And we can make it a negative 10 by multiplying the bottom by 2, in which case I get negative 6x minus 10y equals 2 times a negative 8 is negative 16. And now I'm going to add these two equations. And lo and behold, this is a strange problem, because 6x plus 6 plus a negative 6x is 0x. Don't put anything down. See, I'm adding those two equations. 0x, 10y plus a negative 10y is 0y, so this side is 0. And when you eliminate a variable, it's one of those weird cases. 6 plus a negative 16 is negative 10. This is a falsehood. It's not right. And if it's not right, there's no solution. No solution. Check your answer. That's it. Perfect. Perfect. 2 more and we're done with this. Yeah, I guess we can fit this in. There's not that much to do here. Word problems. I love their word problems. Jurassic Zoo charges $14 for each adult and $7 for each kid. Okay. The total bill for 114 people from a school trip is $10.50. How many adults and children went to the zoo? Okay, we have to come up with a couple of equations. A is adults. C are children. Assuming children are people, when you add A plus C, the total number of bodies that went there are 114. Okay, that's one equation. Now we have to deal with the money. So every adult that went had to pay $14. So 14A would be the amount of money due to adults. Plus, for every kid, you've got to pay $7. 7C is the amount of money for each kid, for kids, and that's equal to $1,050. Okay, that's the hard part. Hard part's coming up with the equations. Now what I'm going to do is use the elimination method, and it doesn't matter which variable you want to get rid of. I keep getting rid of the second variable. It doesn't necessarily have to be that way, so I'm going to get rid of the first variable. And the way you do that is, it would be really nice to have this A have a negative 14 in front, so I'm going to give it a negative 14 by multiplying both sides by negative 14 and putting the answer right below. Negative 14A. Negative 14C. And now I'm going to need a calculator. Negative 14 times 114, huh? Okay, here's my calculator, calculator right there. Clear it. 114 times 14 negative, I get 1596 negative. So negative 1596. Okay, now watch how it happens here. We're going to add these two equations. 14a plus negative 14a, 0a. 7c plus a negative 14c is negative 7c. And now what I'm going to do is say 1050 plus a negative 1596 is going to be negative 546. Negative 546. And now for sure, you better get a whole number because you can't have half a kid. Divide both sides by negative 7, and you get 78 kids. If you get any decimals, you did it wrong. 78 kids. So I'll put kids here. Make sure you put it in the right box. 78. So how many adults? Well, look at this. If 78 kids went and the total number is 114, how about if you subtract 78 from 114? Okay, to get 36 adults. Check your answer. Nice. Very nice. Last but not least is another word problem. They love those word problems. Let's see what happens here. File, new sheet of paper. And we're going to be done with this very, very soon. So here we have a journal that has 8 full-page ads and 6 half-page ads generating 6120. So you got this magazine. They advertise that you can have a full-page ad and a half-page ad. And apparently this person went all out and went and had 8 full-page ads in this magazine. So that's the amount of money they had to pay for the full-page ads, plus 6 half-page ads. Come up with variables that would sort of remind you what you're trying to solve for. So 6 half-page ads is the amount of money for those half-page ads. So the total bill that you have to pay them is $61.20. Okay. The next issue has 7 full-page ads and 7 half-page ads. So there you have to pay $58.55. So 7 full-page ads plus 7 half-page ads is equal to $58.55. Okay. It's the only thing, I think those equations are right. Those equations are good. Let's see. The only problem with this is that the numbers are huge, and you've got to get out of the habit of saying, getting onesies and twosies for answers. These are legitimate numbers that you need to manipulate. And that's what you have calculators for. That's what you have calculators for. So what do we want to solve? They were asking for the advertising rate for half-page ads. So we want to eliminate the full page. They just, I hope there's not another answer down here, but let's hope that they just want half-page ads. You don't want to eliminate the H because you're eliminating the half-page ads. Let's eliminate the F, the full page. What I want to do is multiply top and this equation by a number, how about 7? That gives me 56. Multiply this equation by -8. That gives me -56. I'm liking it. So let's rewrite these equations. This is 56, the top equation, plus 56F plus 42H is equal to 7 times 6120. So thank goodness for calculator. 6120 times 7 equals 42,840. Okay. The bottom guy now is -56F minus 56H is equal to -8 times 5855. 5855 times -8 is a negative 46840. Okay. Let's add those two things up. And yep, the 56F and the minus 56F go to 0. 42 plus H plus negative 56 looks like it's a negative 14H is equal to, now let's add those numbers. It's 42,840. I get 4,000 negative 4,000. Okay. Now let's divide by -14. -14. I don't think this is going to come out even, so cancel. H is equal to 4,000. The negatives cancel, so 4,000 divided by 14. Here's what I get. H is 285.714286. That's what's on my calculator. Round to the nearest cent, so I'm not too worried. Here's your nearest cent. Okay. 4 is a small number, so we can just dismiss it. Dismiss those digits. So what I'm going to put in here will hopefully be the right answer. 285.71. Hit enter. Nice. I hope they're not going to continue this. Yes, they are. Yes, of course they are. Of course they are. So what I'm going to do, round to the nearest cent. Okay, so pick an equation. Pick an equation. I'm going to say 8F. We want the full time, not the full time, the full page. 8F plus 6 times this number here is equal to 6120. Okay, let me just say times 6. Okay, so this is 8F plus 1714.29 equals 6120. Subtract this number, 1714.29, from both sides. And this is what I get on this side. 8F is equal to 7171, and divide by 8. I get 550.714286, and I only want cents. The rows, that's a small digit, so get rid of it. So I'm hoping that I get 550.71 there equals fantastic. Well, I think that's it for this homework. Yep, that's it for this homework. And so we're done with Chapter 4. Do this homework. There's a quiz. Remember, there's a quiz associated with Chapter 4. Do that. And we'll see you in Chapter 5.